you all about the half that is in front, okay, over here, and then also the way that the shoelace works is to multiply, okay, in this direction, then add up each pair together, then we minus away in the same manner for the other side, okay. So today yesterday I shared that today I will teach you the area of quadrilateral. So for quadrilateral, it will be in this manner. Because for quadrilaterals, there are going to be 4 corners. So there will be one extra pair, x4, y4, and go back in the loop to be x1, y1. Okay, so triangle. And quadrilateral. Quadrilateral is any 4-sided figure. So the conditions for this shoelace method is also the same way. So we pair it like that, diagonally across, multiply, then sum, then minus away the other direction. Okay, so key notes is that coordinates must be arranged in anti-clockwise manner. So yesterday I shared that we have exercise 7.4 question 1b. We found out that the area of the triangle is actually 29 units squared. Anti-clockwise manner, I wanted to show you what happens if I have it in a clockwise manner. Okay, so if I had done it in clockwise manner, which is not correct, okay. I will have, starting with A, 5, 4, I'll go over to C, 8, -6, then 1, -2, and I complete the loop with 5, 4. Okay. Then after that, I need to cross and multiply. So like that, right? I would have equals to half times 5, -6, plus 8, -2, plus 1, 4, minus away the other way round, which is like that, 8, 4, plus 1, -6, plus 5, -2. Okay, I would have gotten -42 minus 16. -42 for this one, minus away 16 for the other one. Then I will find that eventually I get -29 units squared. Okay, so when you get a negative answer, alright, you need to realize that there must be a problem, and the problem will most likely be because you took it in clockwise manner. Okay, if you realize, no, down here you still do it anti-clockwise manner, and down here you still get negative, right? Then the mistake will probably be lying over here. Okay, that you did some calculation error somewhere already. Alright, otherwise, by anti-clockwise manner, surely your answer should be a positive answer. Okay, so when negative answer, just do a check, right, to see where you went wrong, right? Because area cannot be negative. You understand what I'm saying? Okay. So I want you to practice now in using the quadrilateral formula to do exercise 7.4 question 2b. Okay, that's on textbook page 186. Right? Give it a try. Tell me what is the area. Give you 3 minutes. Most of you are able to do static. We should be getting 43 units square. Very commonly tend to actually forget to have one more pair of coordinates. Okay, so regardless of where you start, okay, so if I were to start here 0, -1, then I could have gone to 9, 2, 7, 5, -3, 4. And then after that 0, -1. Right? Then if you key the entirety to the calculator, in the sense of the after you do the cross and all that, right? you should get equals to half times 28 minus negative 28. So, sorry, wrong. What am I doing? Probably wrong. 76 minus away negative 10. So we should get 43 units squared. Okay? Any questions? Right, if not, let's go on to question 3b. Okay, from the textbook, exercise 7.4 also. So in question 3b, right, they did not give you a diagram. Okay, they only gave you the coordinates for the vertices. Right, vertices are the corners of the figure. Right. So when you're given things like that, how to actually go about finding out the area then? What would you have done if you still want to use that formula? What would you have done? Kelly, what do you think? What would you have done? I'm given the coordinates. I want to use the formula. But that formula has a condition that it must be anti-clockwise manner. Sketch it, very good. Okay, so we got to sketch it. Alright, so this is where the sketching is necessary so that we know how the order looks like. Okay, your sketch need not be accurate, okay, but at least it needs to be neat enough for yourself to be able to read and understand. Right? So negative 4, negative 2 maybe around here. Okay. Then negative 2 and 4. And 6 and 0. Okay, so after drawing this sketch, you know the location already, then you can very well know that, okay, how the anti-clockwise manner will work. It doesn't matter where you start as long as you go in anti-clockwise manner. So you can start here, go in this cycle, or start here, go in this cycle. Okay, so will you take another 3 minutes to find out the area of this triangle by using the shoelace method? Okay, take you 5 minutes to do so. squared. Right, I will not write down the working. Okay, so let's take a look at try 12 now. Right, we are given the coordinates of 3 points A, B, and C. Okay, and then the area of this particular triangle is 11.5 units squared. We want to find the possible values of K. So the K appeared in this point here, okay, for B, which is K1. Okay, so because the value of K is the x coordinate of B, I wouldn't exactly know where this point B is going to be. I only know that the y coordinate is 1. Okay, so I can only roughly know that if I have the line y equals to 1 over here, okay, it will lie somewhere along this purple line. Okay, so it will only lie somewhere around here, but I don't know where. Okay, it can be here, right? But then, okay, because of the unknown location of this point B, right? Okay, it can affect our answer greatly. Because if I have my point, let's say here, right, then the triangle that I will draw, okay, will be in this manner. And the way that I take my anti-clockwise direction will be AOB. Okay, so B is here, right? But then, if I were to have my triangle, or rather have my point B somewhere on the other side, okay, let's say around here, then my triangle is going to look like that, and the anti-clockwise direction that I will take will be ABO. You see that? Okay, and because of the change in the direction of, or rather change in the point B, right? Okay, it will affect the answer greatly. So there are actually 2 cases that we will need to consider, and that is the reason why there are possible values for K. Okay, so when the question actually says what are the possible values, usually there are 2 cases that we need to consider, right? Okay, but then in the exam they will put it in the more tricky manner lah. Okay, so sometimes they say find the value, then put bracket around the S. Okay, then that is usually how exams will be faced. So it is really dependent on yourself to realize, okay, the different situation, right? So let me resume back the original phrasing. Find possible values. Okay, so let's work on AOB first. Alright, so if B is on the right of O, okay, is to the right of O, right, maybe, right, yes. So the area will be considered as half 5700, and then K1 followed by 57 again. So opening up that bracket, 5 times 0, 0, 0 times 1, 0, K times 7, 7K, minus away, 0 times 7, 0, K times 0, 0, 5 times 1, 5. Right, so that will arrive for us an expression which gives us 5 minus 7, 7K minus 5. And this area given in the question is equal to 11.5 units squared. So this forms for us an equation for us to solve that 7K minus 5 will be equals to 23. So 7K is equals to 28 and K is equals to 4. So that is one possible value of K. Then for the next case, we do the same thing, but for ABO instead. Okay, so if B is to the left of O, right? We will arrive at this. Okay, I'll give you maybe about 4 minutes complete this and find the other value of k. You'll get the answer. What is the k value? What is the other k value? Emily, what do you get? -2, 2.57. Can it be expressed as an exact value? -2 and can it be expressed as a mixed number? Cannot. You sure? What about the rest? Nicole, what do you have? 4 out of 7. Emily, could you check? You should be able to get the exact value. Yeah. Yes. Where am I in? What? It doesn't matter. Yeah. Okay. Any question? Alright, let's look at try 13. Okay, so here onwards, right? Okay, the questions are actually usually typically for this chapter very long and lengthy. Okay, combining everything that you know about parallel lines, perpendicular lines. So one question in your A-Maths can like that for this chapter can be 10 to 12 marks. Okay. So that's why it's very important for us to remember the different properties of quadrilaterals. That one we studied in Sec 1 or Sec 2. Okay, at least Sec 2. So let's look at try 13. Something that I want to add on to this question, right? I find that the diagram is very poorly drawn, first of all. I cannot see that it is a kite at all. I don't know whether you can. I mean, you look at the diagram in page 184 of your textbook. Okay. Upside down. I mean, from the one in the textbook, I find that it is difficult to tell which are the lengths that are equal to each other. I don't know whether you feel the same way as me. Alright, I find it very difficult to know which are the two lengths that are equal because we are referring to a kite in try 13. Okay, it is a kite ABCD. So in what I have here, right, it's slightly maybe a more accurate representation interpretation of what the question wants, and to add on to the questioning, I want you to write down or add on that this is the crucial piece of information which I find the question lacking. Okay, to say that AD is equals to CD and AB equals to PC, because the diagram failed to represent this very clearly. Okay, and yet they never put it on words. Otherwise, you cannot solve for part 2 onwards. Okay. So in part 1, alright, we are told that there is a line 9x plus 2y equals to 13 and 8x plus 9y equals to 26. They are not shown in the diagram at all. The two lines does not refer to CD and BC. Alright, please be very careful. These two lines are just lines up of the diagram. They meet at the point C, and we want to find the coordinates of C. So how should we go about doing that to find the coordinates of C? Chpt, what do you think? Yes, simultaneous, okay, because they intersect, very good. Okay, so we do our simultaneous. Okay, so we can do substitution or elimination, whichever that you prefer. Coordinates of D. So we got the coordinates of C already, which is 1, 2. Let me just put it here. Right? We know that it is a kite, okay, and just now I gave you the extra information that AD is CD, okay, and then after AB and CB are actually equal in length. Right? How would you actually go about finding the value or the coordinates of D? Okay? The question says that D is actually on the x-axis, right? So could we maybe let D be a certain set of coordinates first? What would the x coordinate be? Or what would the y coordinate be? Question says D is on the x-axis. So how? So what do you think? D is on the x-axis. Sorry? Y equals to 0. Okay, yeah. So we let the y coordinates be 0. X coordinate, we can let it be any letter that we want. Okay, so let it be x. Right? So we define it this way. Okay? But what next? Right? We need to go and find out the value of x. Okay? We only got the information about the kite. AD equals to CD and AB equals to BC. So what will you attempt to do? Hannah, what do you think? Sub the point into this equation. Into this one. Why into this one? This equation represents CD. Just like I said, right? These two equations are not related to the diagram at all. Okay, so this and this don't match, right? So that means these equations cannot be used entirely. Then how? Find the gradient of CD and AB. But this is a kite. Kite got no parallel lines. And we don't have coordinate of B and D, so confirm cannot find the gradient. At most we find the gradient of AC, which doesn't help us in finding D. So the only reliable source of information is this one, right? What can we do with this? Ideas? It's done. You want me to teach you maths? She can, I think. Just like I cannot teach you English.
We use Pythagoras theorem to find the length of the side.
Use Pythagoras theorem to use the length of segment formula lah.
Yeah.
Don't need Pythagoras theorem lah. Okay. Yes. Okay. So we can find the length of the sides. Which sides are you referring to?
A, B, and C.
Okay, we can find the length of AD and CD because they are equal. So that would mean that we have 3 minus x squared plus 3 minus 0 squared. Okay, equals to, then CD is 1 minus x squared plus 2 minus 0 squared. Okay, then after that, we can remove the square root sign because just square both sides only. So 3 minus x squared gives us 9 minus 6x plus x squared plus 9 equals to 1 minus 2x plus x squared plus 4. Can simplify this. Okay, then I cancel x squared. So the point D will be 3 1/4 and 0. Right? So actually that's the problem about kites. Okay, kites don't give you much. Isn't able to help you, or rather, okay, sorry. Kites, okay, don't have any parallel lines, don't have any perpendicular lines for the sides at all. So we cannot use any of those kind of information for us to form any equation such that I can find a gradient and all that, right? So finding gradients is a bit slightly impossible, okay, when it comes to kites, unless, okay, since we're talking about kites, one important property about kites is that the diagonals, okay, itself, they actually cut each other, okay, perpendicularly, and in fact, okay, the longer diagonal is a perpendicular bisector of the shorter diagonal. Right? This is an important property that we may use when it comes to kites. Okay? Because perpendicular bisector. Is this what?
Important exam.
If not important, I say for what?
Wait.
Everything I say is important. Everything I ask is also important. Okay? So longer diagonal is a perpendicular bisector of shorter diagonal. Alright, sometimes with this information, okay, it may actually help us to find out equations of these lines, and then it may help us to find out any coordinates also. Although we are not using this this information for this question. Okay. Alright. So then next in part 3, we want to find the coordinates of B. Okay, which is the remaining last vertex of this kite. But I want to emphasize that a kite is not a parallelogram, so we cannot use the same way that we do for parallelograms to find the coordinates of the fourth vertex. Okay, because like I mentioned here, it is only the longer diagonal that bisects the shorter diagonal. Okay, the shorter diagonal does not cut the longer diagonal into two equal halves. Okay, so that's why the midpoint of the diagonals are not common. Alright, so therefore we cannot use that midpoint method, okay, to find the coordinates of B. So then this brings us to a problem. How do we find the coordinates of B? What do you think? How do I find the coordinates of B? Huh? Yep, so we do the same way as how we did in part 2. Okay, we do AB equals to BC. And very importantly is because we have B, okay, to be on the y-axis such that we can let the coordinates to be 0, y. Okay, but then I want to ask just extension question. What if B is not on the y-axis? What if my diagram is maybe drawn like that instead, up of the y-axis? Then how? I got ACD lah. What will you have done? Can find or not? I just don't know, I just ask. Is it possible? Huh?
Find the gradient of BC. Find the perpendicular bisector.
Okay, so the idea that Mervin says is that we find the gradient of this line, then we can find the gradient of the perpendicular bisector. We can also find the midpoint of this diagonal, AC. Then we can have the equation of this longer diagonal. But even if I have the equation of the longer diagonal, I still need one more equation to solve simultaneous. Right? So we are lacking information unless the question gives more information. Right? Yes?
What they give like the two gradients, like there's one gradient that belongs to BC and one gradient that belongs to CD.
BC?
And CD.
Where got this gradient?
The top one. Oh, never mind. I think my brain stopped really very.
What did I say about part 1?
Oh, yeah, sure.
The two equations there don't belong to this diagram.
Oh.
Yeah.
My brain stopped really.
Okay, so actually if I had moved this B out, right, okay, away from the y-axis, I am lacking in information unless I tell you that there's some other line that passes through B lah. Okay, so I'm just trying to stretch your thinking, right? May come up for exam, I don't know. Okay, but kites are common to be tested. So give you maybe 5 minutes, solve part 3, find the coordinates of B using same method as per in part 2. Use the part 2 method. Yeah, the next one. AB equals to BC. hope that you get your y, or rather the y coordinate, okay, to be 6.5, right? So B should be 0, 6.5. Okay, then after that, for area of the kite, leave it yourself for you to calculate. Okay, it is the same formula. We should get 8 and 1/8 units square. Right? Please make sure you write unit square, okay, when you find the area. Not cm, because question never says cm. Unit square is considered a unit for this question itself. Okay, next we move on to try 14. Okay, so in try 14, we are given a trapezium, right? We have PQ and RS to be parallel to each other. Then SP is perpendicular to the parallel lines, right? Sorry, my diagram is not very well drawn. Okay, something like that. Right, then after that, they give you the coordinates of PQ and R. Okay, so in part I, we want to find the equation of RS. So how do we go about finding the equation of RS? What do you all think? How to find the equation of RS? Amanda, what do you think? Find the gradient of, very good, okay. So gradient of PQ will be -8 minus -2 over -2 minus 4. That's one. So what if I find the gradient of PQ? Amanda, what was the intention? Okay, it's y minus y1, okay, not y1 minus y, right? So, because the gradient of PQ is going to be the same as the gradient of SR because they are parallel, so the equation of RS will be y minus away, okay, the point of R, 4, equals to gradient 1, x minus 2. So we make use of the coordinates of the point 2, 4. And we will get y to be equals to x plus 2. So that's how we get the equation of RS. Next, part 2, we want to find equation of PS. How do we do that? Equation of PS. Wayne, what do you think? Part 1. What do you want? perpendicular to RS. Okay, so what about it? Okay, good. So the gradient of PS is actually equals to -1 over the gradient of RS, which is actually 1, right? Okay, so do you catch what I said? So that's why it's -1 over 1, right, which is -1. Okay, then how to find the equation then? When can you complete it? We got the point P to be -2, -8. Up to you, whatever method that's comfortable for you in terms of finding equation. You know how to find equation of straight line? You don't understand this one, never mind. Do whatever that you know. Sorry? Sorry, what thing equals to? -8. Okay, equals to? -1 times -2. Then plus C. Okay, so we use y equals to mx plus c. So -1 times x plus c. We use the point P. Okay, get 2. C equals to -8 minus 2, -10. So therefore, it will be y equals to -x minus 10. Right? So if you're comfortable with the Emacs way of finding, that's perfectly fine. As long as you get an answer. That's quite important. Yes? You sure? How far is the minus sign, right? Okay, so if you use the y minus y1 equals to m times x minus x1, it should be what you have in your substitution. Okay, then after that in part 3, we want to find the coordinates of point S. Alright, so we have already gotten the equation of RS, which is y equals to x plus 2, and the equation of PS, which is y equals to -x minus 10. To find the coordinates of S, we will do simultaneous equation solving, right? Same thing, use the formula. Okay, I give you maybe about 3 minutes. Apply the formula. Part 4, find the area of trapezium. area of the trapezium? What did you get, Chloe? Sorry? Great. Okay, 56 units square. Anybody not get the answer? Right, if you didn't get, maybe it's something wrong with the calculation, but please check that this is a trapezium, so there should be 5 pairs, okay, of coordinates in your formula itself. Right, now let's take a look at exercise 7.4, question 11. Okay, something slightly challenging. We are given this rectangle here, okay, and we have only this point C, which is 4, 3. Question has also shared that AB has this equation, AD has this equation, right? In part I, we want to find the coordinates of A. Oops. Okay, I believe you can find the coordinates of A, right? Zhen Quan, how to find coordinates of A? Sorry? Yep, simultaneous. Okay, so can I give you maybe 4 minutes to do simultaneous? Find the coordinates of A, please. So coordinates of A is -2, -5, alright? Next we move on to part 2, okay, where we want to find the coordinates of B and D. Okay, I shall not do all the working. Right? Anybody didn't get -2, -5 for A? Okay, so next we look at part 2, right? We want to find the coordinates of B and D, right? This question says that it is a rectangle. Okay, so rectangle will have some properties. So when it comes to first, if you want to find the coordinates of B, how would you go about doing that first? What do you think you would have done, Bernice?
Start the 4 and 3 to the equation of B.
Sub this equation of this 0.43 into? Into here. But this one is for this line. They are parallel, but you take this one sub in here. They are parallel, so what? Parallel same gradient doesn't mean that the point lies on that line. So what do you try to say? What will you try to say? You know this one cannot sub in here, right? Yeah, okay, understand that, right? Yeah. So parallel, that means what does parallel lines mean? Same gradient, so we need to extract what out of here? Yes, so we need to extract the gradient out of that line. Okay, so we shift the y to the right now. So we get y equals mx plus c. Okay, and then we have the gradient of AD, to be the same as gradient of BC, which is 3. Okay, so we got the gradient for the line BC already. Then we got the point C, so we can form the equation of BC. So that will be y minus OB3 equals to gradient x minus OB4. And we have the equation of the line, y equals to 3x minus 9. Okay, then how to find point B? Simultaneous, yep. So there's really a lot of simultaneous that we have to do. So simultaneous with x plus 3y equals to negative 17, because that is where point B lies on. Okay, lies on both of this line. So we got the coordinates of B to be 1, negative 7. Okay? Then last one, we want to find the coordinates of D. Okay? There are many ways to find coordinates of D. Okay? How would you find coordinates of D? There are many ways. I can think of 3 ways to find coordinates of D. So this will be a test of concepts. Karen, what will you do? How will you find the coordinates of D? Use the same method. Sorry, repeat. X coordinate of D, X coordinate of D, A. Never mind, take your time, face the sentence. You're going to the yes or what? Oh, okay. So you want to see compare the difference in the x coordinate between A and B, is it? And the y coordinate. Then after that, match it over here to look at the difference and change. Yep. Okay. That is perfectly fine. Alright. So what Jared is saying is that. So let me write down one method. Okay. How did I phrase it? Observe the gradient changes. So by doing this method, what Jared was trying to say is that because the gradient of AB and gradient of CD is the same. Okay, so the changes in the x coordinate and the y coordinate will also be the same. Do you agree? Okay, so the way it change will actually be the same. And more importantly, okay, it will be exact, okay, mapping of change x coordinate over here, change the y coordinate and change the y coordinate over here, because, okay, AB is the same length as CD. Okay, so since AB parallel to CD and also the fact that AB equals to CD, okay, we look at from A to B, x increases by how many units? This is 1, -6. Increases by 3 units. And y coordinate actually decreases by 1 unit. So it will happen the same way from D to C. Coordinates of D will be kind of in reverse. Sorry, I should have done a better job here in writing. Okay, so now we have to end up doing it in reverse. So D to C, so we now see from C to D. So we have 4, because it increased from A to B, so minus away 3. We look at opposite direction. Okay. 4 minus 3. And then after that, the y coordinate, instead of decreasing, will now increase. So we get 1, 4 for coordinates of D. Okay, do we get this idea? Understand? Okay, so I'm sorry, in my phrasing I didn't do it very well. Okay, because of the opposite direction, that's why instead of +3, okay, to map out this increase is -3, because I go in the opposite direction. From instead of A to B, now it's from C to D. Okay, so this is one way, right? Any other ways instead of having to write all this? Because you can see that Jared had probably some difficulty in phrasing this out. Yes.
Length of AC equals to length of D.
Length of AC equals to length of BD. Alright? But the problem is that midpoint, you're talking about length then.
Everything.
Yeah, okay.
I read sorry.
Okay. So you're somewhat there. Okay. So just now what Joseph says, if we look at length of AC and length of BD, yes, the diagonals are going to be of same length. That's a property of your rectangles. But the problem is that D, okay, has both two coordinates that are unknown, x and y. So end up we need to have simultaneous equation going on, and that's going to be very tedious. Okay, so then that's why he hit a point on midpoint. Okay, so you need to recognize that this is a rectangle. Rectangles are also parallelograms. So another method is to actually make use of midpoint. Right, and this can only work if your diagram is a parallelogram. So midpoint of CD will be 4 minus 2 over 2 and 3 minus 5 over 2 equals to 1 plus x over 2, negative 6 plus y over 2, where we let D be x, y. So 4 minus 2 is 2, 1 equals to 1 plus x over 2. 3 minus 5, negative 2, negative 1 equals to negative 6 plus y over 2. this is the second method, okay? And of course, third method, alright? Any ideas for third method? Emily, just now you wanted to say something. Is it the midpoint one? Okay. Is it the third method? Third method would be, okay, because we can do the same way as for how we found coordinates of P actually. Right? I can find out the gradient of CD since it is also parallel to AB. Then after that, I find the equation of CD and do simultaneous again to find E. That is also possible. Okay? So I will not go into writing that method now. Okay, so use same way as finding point B. Why is it that I want to run through all the three different methods is that okay, we cannot limit ourselves to just one method only. Right? When it comes to the first method here, right? Okay, it is only possible okay, when there are parallel lines and that the parallel lines are actually equal. If the parallel lines are not equal in length, we cannot do this comparison anymore because the change will be different. Okay, it is not a constant set of changes. Alright, so there's that one assumption that we rely upon for this method 1. Then when it comes to method 2, okay, it can only happen if your diagram is a parallelogram. That's why understanding what is a parallelogram is important. If I give you a trapezium, then this method will not work anymore. Alright, likewise if I give you a trapezium, okay, for this first method, it will also not work if your two lines are actually not parallel to each other. Okay, and then for point number 3, right, it can work for trapeziums, okay, because there might be a possibility for you to find the equation of the other lines. Right? Then after that, you can solve it simultaneously to find what is the coordinates of the 4 point. Right? So understanding all the three methods and the assumptions behind it, right, will be important for you in terms of deciding what method to use in the exam. Okay? Right, so end here today, but homework, okay, 7.4. Homework will be question 8, 10, 13, 14, 8, 10, 12, 13, 14. Where should I write it? Okay, so please complete the questions, right? It will be due on Friday, possible? Okay, Friday? Right, so due on Friday. Okay, thank you everyone. Thank you everyone.